So this is tutorial number 21, oxygen at 20 degrees Celsius and approximately 1200 Pascal absolute. ABS is showing the absolute pressure. Okay, flows through a 35 micrometer diameter smooth capillary tube at an average velocity of 10 centimeter per second. Estimate the Knudsen number of the flow and whether slip flow will be important. So here I propose to you to study a little bit about the Knudsen number, because Knudsen number is the dimensionless number. We have commonly in fluid mechanics, we have a Reynolds number, and then we could have a Froude number, and so on and so forth. So every dimensionless number will give us sign whether certain phenomenon occurs or not. So the common one is the Reynolds number. If you have the Reynolds number, you know whether the lamina and turbulent occur or not. You could determine the transition between the lamina and turbulent. So, and then the Knudsen number is actually the number who could tell us whether the slip condition is occur or not. So means that you could you could know whether your calculation need to be use the idea of slip condition, or you could neglect the slip condition. You just assume it is no slip condition. Okay, so let's say we try to solve this one. And again, another thing, I hope you could understand that there are two types of pressure. So we have two types of pressure. One is absolute pressure and one is gauge pressure. So I hope you could understand this. So let's say in this situation, the molecular weight of oxygen is 32. So, and then we could calculate the gas constant as 8313. In certain textbook, they will use 8314 or 8313. Okay, 8314 divided by 32, you will get it is 260. So, and then you could check the dynamic viscosity of the oxygen at 20 degrees Celsius is almost 20 times 10 to the minus of 6. So, and then the density you could calculate according to the pressure given here. As I said, if you are dealing with gas, please make sure that you take care about the pressure and the density, because it is very fragile. Fragile means it can change easily. So the density at this situation is 0.0158 kilogram per meter cube. And then we are going to calculate the speed of sound. So A is equal square root KRT. So K here is the constant for the air. So, and that, okay, K is actually the constant numbers. Normally air is 1.4 and oxygen also has the same number, 1.4. So the value of K here, so you need to check you need to check when you use your calculation. If you use nitrogen, maybe you need to use 1.3. Okay, so and then we substitute the value of R, we substitute the value of temperature, so we get the speed of sound is 327 meter per second. So all of this is actually the parameter that we need to calculate the Knudsen number. So and then we try to calculate about the mean free path L. So mu is equal 0.67 rho LA. So it is from the textbook. We just use the value. So and then we could calculate the value of A is 5.78 10 to the power of negative 6 meter, and Knudsen number can be used of this one. So here the value of speed of sound, and this is the value of density. So the 0.67 is a constant. So we substitute everything, we get the L, and then we substitute into the Knudsen number here. So we get it is 0.165. So the limitation of the Knudsen number here, if the value of Knudsen is less than 0.01, so we assume that the fluid is continuum. So the fluid is continuum means fluid is flow as usual. So means that the slip is not occur. So you could use the idea of no slip condition. So and then if the value of Knudsen number is greater than 0.01, so it's better for you to assume that the slip flow is occur, and you need to use the idea of slip velocity in your calculation. So all this calculation actually is very important when you are doing your simulation. So in simulation, you need to determine every very carefully, especially if there is a slip condition like this, then you need actually to modify your Navier-Stokes equation later on. That's why in Navier-Stokes equation, normally people will use the idea of no slip condition. So, but it depends. You could discuss with your supervisor later on.